Hey Math Marvels, this is Sarah, and today we're going to go over the 2022 6th grade math exam from the release questions on the New York State Education Department. So here's some quick things to know about this exam. First things first, not every question will be on it. The state actually takes some questions off, so if you see that I've skipped any problems, it's just because those questions were not included in the actual handout, and I am of course linking the actual site if you want to get your own copy of the test to do as practice before you review any of the questions. Okay, so this was based on the 2022 exam. I'm going to tell you what's going to be on the 2023 exam for New York State. First things first, here's the design of the test. There are 46 questions. On day one, you're going to have 30 questions, all multiple choice, and on day two you're going to have 16 questions, which will be made of multiple choice and a 1-pointer, 2-pointers, and another 3-point question. So this will be the new makeup. The 1-point questions are brand new this year. Last year they would have been 2-point questions, just comprehension, probably computation problems. Here you're going to have 3 1-point questions, 6 2-point questions, and 1 3-point question. This is also going to be the day that you're going to be able to use a calculator. And on day one, you have to show that you can do all that work on your own. So no calculator on day one, but there is a calculator on day two. Here's the other thing I want you to know before we start going over the questions. This is the makeup of the exam itself, the entire blueprint. This is what teachers use to kind of plan out the entire year. First thing I want you to know is that any stats and probability problems will not be on this test. Those are taught after the state test, after May 6th. And you'll get 4 different types of questions. RP or ratio problems, you'll notice they are anywhere between 21 and 30% of the test. Number systems questions, those are computation type problems, so a little less than a quarter of the test. And the biggest portion will be your EE questions, your expressions, equations. This is basically your algebra, and that might be almost half the test, so anywhere between 25% to 43%. And the last section will be geometry, which is again up to 24% of the test. So this is what you're going to see, and as I'm modeling through problems, I'm going to really show my strategies and my thinking. And lastly, before we jump in, there are some problems that will have a multiple skills. So you might see some geometry problems that use algebra because you have a formula, you need some algebra skills to solve it. Or you might see a ratio problem that needs computation work with positive and negative integers. So those are called dual problems, but they'll be counted more so as the primary. So if it's mostly an RP problem, we'll count it as RP. So I'm going to stop there so you can jump into the question. So before you even start, make sure you have your practice set ready so you can check your answers with mine. And if you're new to the channel, welcome. Ask as many questions as you like. Thank you for being here. We love questions, we love comments, and we're here to help. And if you're a returning Math Marvel or parent, thanks for coming back. All right, I'm going to hit pause for a second so I can get my questions ready, and I hope you're ready too. Here are the first 2 answers. If you got any of them wrong and you're not sure how to solve them, I'll go through them with their various strategies. Starting with the first one, which value of m makes the inequality true? So here are 2 strategies that you can use. In the first one, I'm going to solve for m. So use that. 3m minus 4 is less than 11. I want the m by itself, so I'm going to first make a 0 pair. I want that negative 4 to go away. And the way to make that go away is by adding its opposite. So now I'm left with 3m on one side and 11 plus 4 on the other is 15. I still want the m by itself, so I'm going to divide by my coefficient 3. 3 divided by 3 leaves me with 1m. To remain balanced, I divide the other expression by 3. So m is a number less than 5. The only number less than 5 is 4. If I had done the second one, I cannot say 5 is less than 5. That is not true. A second way I can see a student solving this is by just trying a number and substituting. So 3 times 4 minus 4 is less than 11. 3 times 4 is 12. 12 minus 4 is less than 11. 12 minus 4 is 8, and that is true. 8 is less than 11, so that's a true statement. If you had tried 5, you would have gotten 15 minus 4 is less than 11. 15 minus 4 is 11. 11 is not less than 11, so that would not have been a true statement. So this works when m is 4. But it doesn't work when m is 5, so A would have been the answer. Let's look at the second one. The farmer places beehives containing bees in her orchard to pollinate the plants. The table shows the ratio of the number of beehives to number of acres in the orchard. If the bees pollinate the plant at a constant rate, how many acres will be pollinated by the 8 bees in 18 hives? Alright, so pretty much I'm trying to figure out what is this number over here. So I'm going to start by making a ratio table. Here we go, and I'm going to start with the first ratio. Let me make sure. I'm going to put B for beehives, A for acres, and I'm going to use my simplest ratio. When I have 3 beehives, they pollinate 8 acres. I want to know when I have 18 beehives, how many acres. So just looking at this, thinking about the ratio, how many times is a proportional relationship? I know that to get from 3 to 18, I can multiply by 6. So I'm going to do the same thing over here, multiply it by 6. 8 times 6 is 48. N is equal to 48. That's one way to solve it. If you didn't see what the number was, you could create an equivalent ratio. I'll show you what I mean. So let's say I had done a table, 3, 8, 18n. I can use cross products to make an equation. So 3 times 18, oops, sorry, let me fix that. 8 times 18 is equal to 3 times a number. And all I did was cross multiply. So 3 times a number, 18 times 8. Let's simplify that part out. 18 times 8. 8 times 8 is 64. 8 times 1 is 8 plus 4 is 14. So 144 is equal to 3 times a number. I'm going to rewrite that as a division sentence. 3 times a number is equal to 144. So I know 144 divided by 3 will give me that number. That is another true statement. So I would have to do division. Remember, this is a day you do not get a calculator. 3 goes into 1 0 times. 3 goes into 14 4 times. 3 times 4 is 12. Bring down to 4. 3 goes into 24 8 times. 8 times 3 is 24, and I get 0. So my number is equal to 48. So either one of those ways will work. My gut tells me that most students in 6th grade will probably use the first one and figure out what is that rate. How many times bigger, how many groups of 3s will make 18, and they would see that it is 6 groups of 3. So they would do 6 groups of 8. Hit pause and jot this down. The net of a rectangular prism is shown below. What is the surface area in square centimeters of the rectangular prism? So the key to this is recognizing the area of each square, of each of these rectangles. Some of these have the exact same dimensions. So this one is 8 by 3. This one is also 8 by 3. So 8 by 3. Here's 3 by 8. Here's another set that's the same. 3 by 5, 3 by 5, and here is 8 by 5 and 8 by 5. So instead of adding each individual box, all 6 boxes, the areas for everyone, watch how I'm going to represent this. Since I have 2 of these, I have 2 8 by 3s plus 2 3 by 5s plus 2 8 by 5s. And now I'll just simplify it. I'll do what's in parentheses first. 2 times 24 plus 2 times 15 plus 2 times 40. 2 times 24 is 48. 2 times 15 is 30. 2 times 40 is 80. And now I can just add these parts. 48 plus 30. And this is 158 centimeters square because it's surface area. So this is one way. I just write it in a smaller part. Another way I see a lot of kids do this is by actually doing all the work in the boxes. And when they do that, they just add up all the areas. So this is another way. And both will work. And so I see some kids literally just doing this and adding all the parts. And you can add it in multiple different ways. Some kids will just double and group them again. And you can actually see the 2 times 24 that I have here, the 2 times 15, and the 2 times 40. Either way, you're going to get the same exact number, 158 centimeters squared. Here are the answers for 4 and 5. And I'll go over to work if you had either of these wrong. If not, skip to the next section. Jake takes guitar lessons that cost $120 per month. Which equation can be used to determine the number of dollars Jake pays for lessons for any number of months? Okay, so as soon as I see this $120 per month, I'm going to express it as 120 x. Well, in this case, they wanted months to be m. So 120 m. And we want to know the cost in dollars that he'll make for any month. So D is equal to $120 per month. So that's my equation. And the only one that matches it is this one here. So why can't it be B? Well, because think about it if he had 2 months. So if M is 2, let's say it was 2 months. Would that tell me how much money he earned? No, 2 does not equal 120 times the dollars. But if I know there were 2 months, I could do 120 times 2 to figure out he's paying $240. So B is just a distractor. Let's go to the next one. Claire has 6 large envelopes and 14 small envelopes. What is the ratio of large envelopes to total number of envelopes? So we're looking for the ratio of large to total. And what do we know? We know that there are 6 large envelopes. And this is again where they get a little tricky because they told us there are 11 small envelopes. They're telling us the 2 parts. We have to be smart enough to figure out what the total is. So if I were to add the small plus the large, I would get 17 total. And that's my ratio. So again, there's a distractor here. It's right here. 6 by 11. Because they're counting on kids to just see those 2 numbers, 6 and 11, and say, oh, the ratio is 6 to 11. But that would represent a part to part ratio, where this is a part to whole ratio. All right, hit pause and jot this down into your notes. Here are the answers for 11 and 12. Take a moment to check your work. All right, let's go through them if you had any errors. What is the value of the expression when x equals 7? So that tells me I'm going to substitute. So I'm going to rewrite my expression. And now I'm going to substitute 7. Now notice, because I have a coefficient, I'm going to use a parentheses. Actually, I want to put that right there. Minus 2, again, 2 times 7 in parentheses, plus 3. So it's a common problem where I've seen some kids not put the parentheses and they have something that looks like this. And that is incorrect because this is telling me that it is 2 times a number. This is 3 times a number squared. So please make sure you're using parentheses if there is a coefficient in front and you're substituting. All right, let's erase this part. And we're going to use our order of operations to solve this. So I'm going to write my order here. I want to make that look really neat. And again, I'm putting the arrow there so we know that these two are left to right. Multiply or divide, add or subtract. Both of these are left to right. Okay, so there's no operation in the parentheses besides this exponent. So 7 squared is the same as 7 times 7, which is 49. Another common mistake. Some kids will say 7 times 2 is 14. This actually means 7 times 7. Let me put that there so you can see that 7 times 7. All right. Minus 2 times 7 plus 3. Okay, let's do our multiplication next. 3 times 49. So you may have to show your work somewhere. 9 times 3 is 27. 4 times 3 is 12 plus 2. So 147 minus 2 times 7 is 14 plus 3. 147 minus 14 is 133 plus 3 gives me 136, which is our answer here. Let's go to the next one. A partially shaded rectangle is shown below. What is the area of the shaded portion of the rectangle? Now clearly, even though they're asking us about the shaded portion of the rectangle, what shape do we see here? We see a triangle. So I'm going to use my area formula for a triangle, which is 1/2 base times height. Our base in this case is 8. So 1/2 times 8 times a height of 14. And you may be saying, but the base isn't a base at the bottom. Well, notice that these two are parallel to each other and they are exactly the same length. So if this part is 8, its opposite is also 8. All right, let's use our order of operations to solve. 1/2 times 8. So half of 8 I know is 4. 4 times 14. And again, this is a non-calculator day, so I'm showing my work. 4 times 4 is 16. 4 times 1 is 4. Plus 1 is 5. Area is equal to 56 centimeters squared, which is right there. Now, another way I've seen kids do this is they would find the area of the rectangle, which is 8 times 14, which would have given them 112, and then they find half of that. So they would do 112 divided by 2, and they will get 56. Either way will work. I just saw a triangle there, so I automatically used the formula for area of a triangle. Hit pause and jot this down in your notes if you had any errors. As you're going through these, if there are questions, if you're stuck on something you're not sure, or you have a different strategy, by all means, put those into the comments. I love responding, and sometimes kids ask me, can you give me another example like this? And I'm happy to go over and share. Let's go into any of these. Here are the answers for 15, 16, and 17. And remember, I am not skipping questions. These are only the release questions by New York State from the 2022 exam. So I'm not skipping. These were the only ones that were released. So yes, you will notice a jump in some questions. All right, a group of 10 science club students are on a field trip. The number of students represents 20% of the number of students in the science club. What is the total number of students in the science club? I'm going to represent this using a ratio table. And because I have part of the students, and I want to know the total, so I have a part to whole relationship. And watch how I represent this. My first ratio, well, first let me write this a little bit more clearly for you so you can see it. Part to whole. So 20%, I'm going to represent that as a ratio 20 over 100. And we know that 10 students represents this 20%. So I'm putting the 10 as the part, and I want to know the total number of students. And I'm going to cross multiply here. I'm going to figure out cross products. So we're going to multiply this way. 100 times 10 is 1,000. And 20 times the number is 20n. So watch what I'm going to do to figure this out. 20 times some number is 1,000. So I'm going to do, well, 1,000 divided by 20 will give me that number. Or I'm just using my fact family. I'm rewriting my multiplication problem into a division problem. All right, 20 goes into 1,000 how many times? Well, 20 can't go into 1, 20 can't go into 10, but 20 goes into 100 5 times. And you bring down to 0. 20 goes into that 0 times. I have to make sure if there are 4 numbers here, I need 4 numbers here on top. And I have my 50. Let's go to the next one. 4 times a number minus 8 equals 4. I want to know what value for x makes this true. So I'm going to solve for x. So watch what I'm going to do. First, I'm going to make a 0 pair. I want this x. So first, I'm going to deal with this constant by making it into a 0 pair. I'm going to add its opposite. And to keep balance, I'm going to do the same thing to the other side. This goes away. 4x is equal to 12. I still want the x by itself, so I'm going to divide it by 4. 4 divided by 4 leaves me with 1x. And I do the same thing to the other side for balance. 12 divided by 4 is 3. There you go. And you can always check your work by substituting. 4 times 3 is 12. And 12 minus 8 is 4. Yep, 4 is equal to 4. So that is true. Employees at a construction company are building a fence around the perimeter of a work site. The perimeter of the work site is 1/4 of a mile. The cost of the fence is $20 per yard. What is the total cost of fence needed for the perimeter of the work site? So the first thing I want you to notice is I have the work site in miles, 1/4 mile, but the cost is in yards. So we're going to have to make a conversion. This means you have to go all the way back to the very front page of your reference sheet and notice 1 mile is equal to 1,760 yards. That's going to be important to our work. So I'm going to go all the way back. And I'm going to put that here on the side. 1 mile is equal to 1,760 yards. When you're taking a test, you can actually take the reference sheet out and have it on the side. I can't do that right now, so I'm just going to have it here written there. All right, so the first thing we need to do is we need to figure out how many yards we have. And we have 1/4 mile, so we need to convert our miles to yards. I'm going to do that using a ratio table. And I'm writing small just because there are a lot of conversions here. So I have miles and yards. And I know 1 mile is 1,760 yards. I have 1/4 miles, so I want to know what n is, that number at the bottom. We're going to cross multiply. We're going to do cross products. So I'm going to multiply these two numbers and these two numbers. So on one side, I have 1,760 times 1/4 is equal to 1 times n, which is just n. So we're going to multiply these two numbers, just put a little 1 underneath, and we have 1,760 divided by 4 gives us that number. Okay, so let's do that long division. Again, I want to give myself space. There's not a lot of space here. 4 into 1,760. 4 can't go into 1. 4 goes into 17 4 times. 4 goes into 16 4 times. And 4 goes into 0 0 times. So I have 440 yards. Okay, and it's $20 per yard. So here's the next part. So I'm going to do the 440 yards times the $20. Put that 0 down. 2 times 0 is 0. 2 times 8 is 8. 2 times 4 is 8. And 2 times 4 again is 8. So that is the amount of dollars, 8,800. And here you go. Hit pause and jot this down into your notes if you had an error. And again, if you're unsure of any of these or if you have a different strategy, be sure to add it to the comments. Alright, Jasmine goes to the store to buy some fruit to make a fruit salad. The list shows the amount and the price of each type of fruit she buys. Which type of fruit costs $1.55 per pound? So here are answers. You should get D and D for both of these. Starting off with the first one. Which of these is $1.55 per pound? So what I'm going to do is I'm going to do price per pound for each of our 4 fruits. So let's make some room. The first one are apples, and they are $4.05 for 3 pounds. So 4.05 divided by 3. So how much is 1 pound? $1.35. Let's find the unit rate for grapes, and these are $4.80 for 2 pounds. I don't need a calculator for that one. That is $2.40. That's the unit rate. So far I still haven't found 155, so I'm going to eliminate apples and I'm going to eliminate grapes. Alright, let's go with oranges. And we'll put peaches. Okay, for oranges we have $7.50 for 5 pounds. So I'm dividing 750 by 5. See, I didn't write the decimal, so I'm going to put it in there. Let's do it again. $7.50. Let's make sure it writes that. Good. Divided by 5. Perfect. $1.50. Very close. Very, very close. But it's not oranges. And peaches, $4.65 divided by 3. Let's make sure it copied that decimal good. Divided by 3, and we get $1.55. So peaches is the winner. Alright, let's go to the next one. The outside temperature of a town is -20 degrees Fahrenheit. What is the change in temperature in degrees Fahrenheit, which would bring the temperature to 0 degrees? So I'm going to make a visual for this. And here's 0. And we know that the temperature right now is -20. So I'm to the left of the 0. And I want to know what would be the change to get it to 0. Well, it would have to be its opposite, +20. So these are just opposite numbers, and that would make a zero pair. And negative 20 plus positive 20 would make your zero pair. I like making diagrams just so we can see them. Hit pause and jot this down into your notes. All right, checking your work here, your answers for 26, 27, and 28. All right, the number line represents the points Q, R, S, and T. Which point represents negative a half? All right, so we're definitely looking for a negative. So we are looking for the numbers that are to the left of 0. So it absolutely cannot be S and cannot be T because they are not negative. So forget this and forget this. We only have Q and R. And we're looking for a number that represents a half, negative a half. So thinking of our 0, here's 0. I know a half has to be between 0 and 1, or negative a half has to be between 0 and negative 1. So R is the correct answer. Why would some students make a mistake and pick Q? Well, they might think of it because they're used to thinking of where the 0 is and where the 1 is, and thinking that a half would be to the left of 1. So that might be a common mistake where kids are thinking a half has to be to the left, but they're not thinking about the negative part, and negative numbers would be to the left of 0. Let's go to the next one. Miss Wilson is buying packets of pencils. Each packet costs $11.52 and contains 96 pencils. What is the unit price of a pencil? Right, I'm going to keep going with the trend and make another ratio table. And I do this because it keeps my work super organized. And I want the price of a pencil. So the unit price per pencil. Okay. Price, pencil. All right, so I know that the price is $11.52 for 96 pencils. I want to know how much one pencil costs. So I'm going to put N there. We're going to cross multiply to make an equation. So over here we have 96 times the number is equal to 1152 times 1, or 1152. You can rewrite this. 96 times a number equals 1152. So I know some kids just turn that into a division sentence. But I also know that since you're doing a lot of algebra in 6th grade, you do know to divide by 96 to just get that number N. And you do the same thing over here. So either way will work. All right, so now we have $11.52 divided by 96. I admit this is pretty ugly. I'm going to admit it. It's not the prettiest one. I'm going to use some of the space up top. Just to help us out. And I'm going number by number. So 96 cannot go into 1. Into that first one. It cannot go into 11. Put in your decimal. So already I'm going to a decimal so I can eliminate C and D. Okay, how many 96s can go into 115? Just one. So even at this point, I already know, just knowing that there's a 1 behind the decimal, that I'm going to eliminate B, but I'm going to keep on going. And I get 2. 96 goes into 192. My guess is going to be 2 times because it's less than 200, and 96 is very close to 100. All right, 96 times 2. 6 times 2 is 12. 2 times 9 is 18. 18 plus 1, 192. And no remainder, so it is 12 cents. Okay, let's go to the next one. That was an ugly number, wasn't it? 12 cents per pencil. But we're still able to do it. All right, next one. 3 vertices of a rectangle are located at these points. what is the fourth coordinate? So I'm just going to make a little sketch. And my first point is 2, 4. So 1, 2. 1, 2, 3, 4. So here's 2, 4. Next point is -2. So to the left. And and -5. So I'm going to go down 5. 1, 2, 3, 4, and 5. So here's -2, -5. Okay, so here are two of the points. They're diagonally from each other because it's a rectangle. And my last point that I have is -2, 4. So I'm just moving over here, -2 and up 4 here. Okay, so what does the fourth point have to be to make a rectangle? We know these points here. So I'm going to need another point right over here. So it has to be something down from this point. So it's definitely going to be at 2 and over on this point. So this point here would have the same x, so +2 and -5. And there you go. So that's all I did. I just drew a sketch. Hit pause and jot this down into your notes. Correct any errors if you have them. So that was the end of day 1. Day 1 only has 28 multiple choice. Remember, you cannot use a calculator for these. So you would go home, you'd rest, you come back for day 2. Day 2 is the day you do get a calculator. Remember, it is just a tool. You get a reference sheet again. I'm still going to keep all my thinking visible on the page. So here's 32 and 33, and it starts off with some multiplication. Let's start. There are red tiles and blue tiles in a box. The ratio of red tiles to blue tiles is 3/5. If there are 12 more blue tiles than red tiles in the box, how many red tiles are in the box? Okay. So I'm going to, let's write down what we definitely have. We have the ratio of red to blue is equal to 3 to 5. And we know there are 12 more blue tiles than red tiles in the box. How many red tiles are in the box? So what I'm going to do here is I'm going to make a ratio table. But I'm going to continue it out. It's not too straight. We can make it straighter. And I'm going to keep on, I'm just going to look to see when, here's 3/5, red, blue. When do I have 12 more blue tiles than red tiles? So right now, in this first one, I only have 2 more blue. So if I went to the next one, here's 6, 10, I have 4 more blue. I'll go to the next one, 9 and 15. Now I have 6 more blue, and you can kind of see the pattern. So these are going by 3s, 3, 6, 9, and these are going to go by 5s. So some kids kind of just fill it out. So 3, 6, 9, 12, 15, 18, 5, 10, 15, 20, 25, 30. All right, let's find the differences. 12 and 20. So I have 8 more blue tiles here. Getting closer. I have 10 more blue tiles. And here is where I have 12 more blue tiles. I want to write that nice and neat. Okay, so how many red tiles are in that box? So that's the other part that's interesting. They're asking how many are red. So this is where the table helps. You can see there are 18 red tiles when there are 30 blue tiles. And this is when there are 12 more blue tiles than red tiles. So I had to draw it all out. Excuse me. What is the surface area of the rectangular prism? Okay, so we have another one with surface area. So just like the last one, let's find the pieces that are the same. So these two are the same size. They are both 8 times 23. And then we have these two are the same. And they both have 8 times 36. And my last one is 23. So I'm looking here. 23. So this part is 23 by 36. So I'm going to rewrite those again into that nice simple way. So I have 2 times 8 times 23 plus 2 times 8 times 36 plus 2 times 23 times 36. Now, this is a day where you can use a calculator. So I'm going to hit pause and put a calculator on the side. All right, remember day 2, you're allowed to use a calculator. So I'm going to use my calculator to triple check a lot of calculations. And I'm going to do the multiplications inside the parentheses. So 8 times 23 is 184. And I will say sometimes this calculator I use is a little funky. It doesn't always exactly write down. So I always check it. So 8 times 36. And that's just in case it makes an error. It happens. So let's see, 23 times 36. Okay, so 2 times 828. All right, now I'm going to double my numbers. So 2 times 184. Again, even though I use a calculator, notice I keep all my thinking on the page. 2 times 288. And 2 times 828. Okay, I'm going to put in all 3 numbers. 368 plus 576. Let's put those first 2. Plus 1,656. And I'm just triple checking to make sure that it has all my numbers written down. 368, 576, 1656. Awesome. And that is equal to 2,600, which is our answer over here. Hit pause and jot this down so you have it as well. And let's go to the next one. Alright, Jasmine goes to the store to buy some fruit to make a fruit salad. The list shows the amount and the price of each type of fruit she buys. Which type of fruit costs $1.55 per pound? So here are answers. You should get D and D for both of these. Starting off with the first one. Which of these is $1.55 per pound? So what I'm going to do is I'm going to do price per pound for each of our 4 fruits. So let's make some room. The first one are apples, and they are $4.05 for 3 pounds. So 405 divided by 3. So how much is 1 pound? $1.35. Let's find the unit rate for grapes. And these are $4.80 for 2 pounds. I don't need a calculator for that one. That is $2.40. That's the unit rate. So far I still haven't found 155, so I'm going to eliminate apples and I'm going to eliminate grapes. All right, let's go with oranges. And we'll put peaches. Okay, for oranges we have $7.50 for 5 pounds. So I'm dividing 750 by 5. See, I didn't write the decimal, so I'm going to put it in there. Let's do it again. $7.50. Let's make sure it writes that. Good. Divided by 5. Perfect. $1.50. Very close. Very, very close. But it's not oranges. And peaches, $4.65 divided by 3. Let's make sure it copied that decimal good. Divided by 3, and we get $1.55. So peaches is the winner. All right, let's go to the next one. The outside temperature of a town is negative 20 degrees Fahrenheit. What is the change in temperature in degrees Fahrenheit, which would bring the temperature to 0 degrees? So I'm going to make a visual for this. And here's 0. And we know that the temperature right now is negative 20. So I'm to the left of the 0. And I want to know what would be the change to get it to 0. Well, it would have to be its opposite, positive 20. So these are just opposite numbers, and that would make a 0 pair. And negative 20 plus positive 20 would make your 0 pair. I like making diagrams just so we can see them. Hit pause and jot this down into your notes. All right, here are your answers for 36 and 37. All right, I'm going to jump in with 36. We're looking for what is the area of the shaded part of the triangle. So we're going to use area equals 1/2 base times height. Here is our base. Here is our height. I know that's the height because it makes a 90-degree angle with the base. So area is equal to 1/2 times 12 times 8. All right, I'm going to start with the first two numbers. Half of 12 is 6. So I have 6 times 8, and 6 times 8 is 48 feet squared. So there's the answer for number 36. Let's look at 37. There was a total of 640 students on school on Friday. Every student either walked or rode the bus to school. If 45% of students walked, how many students rode the bus? So this one's interesting. First thing I'm going to kind of do is I'm going to give you a visual just so you can see the percentage we're looking for. So out of all the students, 45 walked and the rest rode the bus. So I know this is 55% rode the bus. So I want to know how many is 55%. So I'm going to make another ratio table. And I want 55%, so I'm going to represent that as 55 out of 100. This is a part to whole ratio. And I know that there are 640 students in school, so that represents the total. And I want to know the part that rode the bus. We're going to cross multiply again. And that means these two numbers, 100 times n is 100n, and 55 times 640. So here's my equation. 100n is equal to 55 times 640. So 55 times 640 on my calculator is 35,200. It's equal to 100 times the number. I'm going to divide by 100, so I'm just left with n, and divide this by 100. Now, I don't need my calculator to know that this is 352. And that's just because I know that when I divide by 100, I'm going to move my decimal 2 times. But if you're unsure, you can always use your calculator on calculator day to double check when you're unsure. And you'll get the same thing, 352. Oops, let's write this down. Okay, jot this down if you need to. Josh has C coins. Nick has 4 fewer than 3 times as many coins. So two things are happening here. 4 fewer, I know that means I'm subtracting 4 from something. And 3 times as many coins is 3C. But that then tells me that this has to come after the 3C. So I have 3C minus 4, which is here. If you had the 4 and the 3C in a different order, I know a lot of kids who are looking for a 4 and a 3C, and they would make the mistake and they may choose D. That would be their distractor. But that is wrong because it's 4 fewer than the other thing. So I have to reverse the order. Hit pause and jot this down, and I'm going to set up the calculator for the open constructive responses. All right, we won't need a calculator for this first part. This is a 2-point question, meaning I'm going to get points for my explanation, the thoroughness, and any work that I have on the page. So let's look at this one. 2 students, student A and B, claim to know the correct representation of the expression 9 over y, parentheses 3t. So student A represents the expression as the product of 9 and y times the product of t and c. Student B represents the expression as the quotient of 9 and y times the sum of 3 and t. Both students' claims are incorrect. What makes each representation incorrect? So that's my goal. I have to be able to say why each of them is correct, and that's going to be a point for each. So let's see what student A wrote. He wrote the product of 9 and y. So that would have been 9y. That is not the same as 9 divided by y. So I'm going to put that in for student A. Student A represented 9y, or 9 divided by y. I'm going to put that in quotation marks as 9y. This is the wrong operation. There is division. Not multiplication. So I know sometimes you're trying to write so much just to make sure you're super clear. Let's look at B. So they're going to look for some variation where you just say like why this is wrong, because that's the error. Let's look at student B. Student B represents the expression as the quotient of 9 and y. So that part's right. So 9 divided by y. And the sum of 3 and t. So, they put 3 plus t, which is not the same as 3t. Student B wrote 3 plus t instead of 3t. This is also the wrong operation. They used addition instead of multiplication. And that's it. They just need some type of variations of something that shows that you know that should have been multiplication. And some kids might even go further and say, well, I know it's multiplication because there is a coefficient next to a variable. You can say that as well. But at its base level, they just want you to be able to make the claim of what the error is on both and how do you know. So that's what I did here. And that will give you your 2 points, one for explaining student A and one for explaining student B. Let's go to the next one. And the answer would have been 51 yards. Again, this is 2 points, but you will not get 2 points if you only write 51 yards. Your work also has to be there. So we have to show our work to get full credit. All right, so let's look at this one. Because you've already done the problem, each unit on the coordinate plane represents 3 yards. So here's the key points. Student A starts at obstacle A, runs south to B, and then west to C. We want to know the total distance. So this kid is running from here to here, and then from here to here. We need both those distances, okay? So distance A to B, whatever that is, plus the distance from B to C. And this key is going to be important. All right, so from A to B, I know that these are how many units? I can see some kids just counting. They'll go 1, 2, 3, 4, 5, 6, 7. So this is 7 units. And we know that every unit is 3 yards. So I'm going to do 3 times 7 to get 21. So this is 21 yards. I'll even go even further and make sure they know 3 units. Just so they know where I'm getting that from. And the next one we know is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we go, 10 units, and 3 times 10 is 30 yards. Again, all my thinking is on the page. 30 yards because this was 10 units. So all together we have 51 yards. All right, didn't even need my calculator, but again, all my thinking, you have to show how you're getting the 51 yards, and they want to be able to see 2 things. They want to see that you're correctly finding the distances. So somewhere, someone's going to look to see that you have 7 somewhere, and that you're figuring out how many yards that is at 3 times 7. So somewhere on the page, it has to say that. And the same thing here, they're looking for a distance of 10 units, and that you are figuring out that 10 units is equal to 30 yards. So some kids go as far as to write that down on the side. If you had just added all these in the 17 times 3, that also would have been fine. I know some kids would have done that and still gotten 51 yards. But that's what they're looking for, that you can show how you got the 17 yards and how you figured 17 units, and how 17 units was the same as 51 yards according to this diagram. Here is another 2-point problem, and you should have 4 plates and 3 spoons, and your work should show how you're getting 4 plates and 3 spoons. So you can't only get credit if you have a 4 and a 3. That would only be 1 point. So let's look at a problem. We know the restaurant orders new plates and spoons. Plates are sold in 9, spoons are sold in 12. The restaurant owner orders an equal number of plates and spoons. What is the least number of packages of plates and spoons they would order to get the equal number? So as soon as I see that, I know I'm looking for a least common multiple. So I'm going to make another long table. And I'm getting it ready because I'm going to do some skip counting. And this will be for plates and spoons. So plates come in 9s, spoons come in 12s, and I'm just going to skip count by 9s first. And I'm going to skip count by 12s. Okay, and I'm going to look for what is the smallest number they have in common. So you're just going to look at both lists and where do they have numbers in common. So I see here they have a 36 in common. Do they have anything else in common? Okay, nope. So that's their least common multiple, but that's not what they're asking us. They're not asking us how many they got. This will tell me they have 36 spoons and plates. So to get 36 spoons, I need 4 packs. You can see here, 1, 2, 3, 4 packs. And for spoons, 1, 2, 3 packs. And those are the answers I put on the bottom. Here is our next 2-point question. Your final answer should be 156 and 1/18 cubic inches. So let's see how you would get this number. And again, your work has to show this. So we have a cereal box with dimensions 12 inches by 7 3/4 by 2. And a pastry box has dimensions 3 2/3, 3 1/2, and 2 1/3, and we want to know what is the difference in volume between the two boxes. So I'm going to just put a line in the middle, and we're going to start with cereal, and we're going to have pastry. So I'm going to put my volume formula. Volume is equal to length times width times height, and I'm going to put these 3 dimensions in. So 12 times 7 3/4 times 2. And the same thing is going to happen for pastry, except I have 3 2/3 times 3 1/2 times 2 1/3. Okay, so here's the kicker here. We have a whole bunch of mixed numbers, a lot of larger numbers, so I'm going to turn all of these into fractions and improper fractions so we can work. So 12 over 1 times 7 times 4 is 28 plus 3. 31/4 times 2 over 1. Let's focus on this one first, and we'll multiply our numerators first. 12 times 31 times 2. And we get 744. And 1 times 4 times 1 is 4. I'm going to simplify that. 744 divided by 4 gives us 186. Alright, let's look at the pastry. We're going to do the same thing. Let's turn all of these into improper fractions. 3 times 3 is 9 times 2. Plus 2 is 11. 11/3 times 7 halves times 7 over 3. I'm going to do my numerators again. 11 times 7 times 7. And I get 539 over 3 times 2 is 6. 6 times 3 is 18. Now, here's the kicker. When you do this division, it's going to be ugly because it's not going to be an even number, and it's going to be a weird decimal that you're going to get. So watch what I mean. So you're going to see something like this, 29.944, and it keeps on going. So here's the challenge. If you did that, you would probably end up having to round and then do 186 minus this number. So it's not going to be that. It's not that it's incorrect. You can do this. So if I just left it this way, and I would do 186 minus 29.944. Didn't put the decimal. You would end up getting 156.056. Again, not incorrect. You would just have to show that you did 186. You just have to show this work somewhere on the page. Now, another thing that you can do, and this is what I did. So I knew 29 was the number. So I actually did, well, what is 29 times 18? And I would have gotten 522. So what would have been the remainder? If 29 times 18 is 522, what would have been left? So 539 minus 522 would have left me with 17 out of 18. So another thing, if you had gone the other route, and I'm showing both, you would have had 186 minus 29 and 17 minus 18s. You have to do some regrouping. So I know some kids would have done 185 and 18 over 18 minus 29 and 17 over 18. That would have given you the 1 over 18. And then you would have just done 185 minus 29. And that would have given you the 156. So those are both options. I'm going to leave them here. So in case you would have done it by decimal, you would have had the work on the top. If you had it as a fraction, you would have to work on the bottom. Both are pretty much the same. So hit pause and jot this down. But notice, look at all this work you had to do for a 2-point question. You have to show that you can find the volume for the cereal, the volume for the pastry, and that you can find the differences between both those numbers. That is all the work you had to do in order to get these 2 points. All right, for 45, it's another 2-point question. You have to show the actual answer. High level is just both students are correct, but you also have to show and explain your answer. So here's the actual question. We have 2 students evaluate the expression 17 times parentheses 4 plus 15. Student A does the product of 17 and 4 and the product of 17 and 15. So here's student A. He does 17 times 4 plus 17 times 15. So he distributed. And student B evaluates the expression by determining the product of 17 and 19. So B does the product of 17 times 19. So how did he get the 19? He just added the 4 and the 15. So he just used order, or she, order of operations. So is each student's evaluation correct or incorrect? Both are correct. Student A used the distributive property. And B used order of operations. And I'm even going to go further to show that both have the exact same expressions. 17 times 4 would have been 68. And 17 times 15 is 255. 68 plus 255 is 323. So that's the value of A's work. And B, 17 times 19, is also 323. So I would even write down both expressions have a value of 323. They're equivalent. And that would have been enough to give me my 2 points. So hit pause and jot this down. You just need something naming the distributive property in the first and naming order of operations in the second, and proving that they are both equivalent values and equivalent strategies to evaluating the expression. Okay, 44 is also a 2-point question. Ultimately, you're getting 20 and 5/10 of a mile. So let's look at how you get that answer, how you show your work to get full credit. You can't just put 20.5 and get 2 points. That would only give you 1. Ryan delivers flowers to 2 customers. He drives 12 minutes at a speed of 40 miles an hour. Then he drives for 15 minutes at a speed of 50 miles an hour. During the 27 minutes of driving, how many total miles did he drive? Okay, so again, I'm going to split between the two. And the first one, he did 12 minutes at 40 miles an hour. So I'm going to make a ratio table. And I'm going to change 1 unit. So he drove for 12 minutes and 40 miles per hour. So notice that I have minutes and hours here. So I got to make a decision. I'm going to use miles and minutes. Not miles per hour because I have minutes in my units. Okay. So 40 miles an hour is the same as 40 miles in 60 minutes. And he drove for 12 minutes. I want to know this top number. All right, cross multiply and you'll get the equation. 60 times the number is equal to 40 times 12. 40 times 12, let's do that very quickly and you get 480. So 60 times the number is equal to 480. Divide both by 60 so we can just get this number. And you're going to get 8. Oops, see, sometimes my calculator is funky. 48 calculator, 48. There you go, 480 divided by 60 equals 8. I told you sometimes this calculator is weird. All right, but it was the easiest way for me to show a calculator instead of the ones that you'll get on the test, which are easy to punch in. I want to make sure I can show my work and have the calculator. All right, let's look at the second trip. He has a whole different speed. We're going to do the same thing, miles and minutes. And this time he went 50 miles an hour, so 50 miles in 60 minutes, and he drove for 15 minutes. So what is this number? So my equation this time is 50 times 15 is equal to 60n. 50 times 15 is 750 is equal to 60n. Divide both by 60 so I have n by itself. Let's see what the calculator does. 750 divided by 60 is 12.5. Alright, so how many miles did he drive in all? So 8 plus 12 and 5/10 is 20 and 5/10. So all that again, you have to be able to show both rates in order to get the final answer of 12 and 5/10. Let's go to the next one. Another 2-point question. This one's actually pretty simple. I won't need the calculator for this. Johnny is 21 years old. He is 3 times as old as Becky. So he's 3 times Becky's age. And so I know 21 is equal to 3 times Becky's age. Write and solve an equation to determine Becky's age. Okay, so Becky's age has to be A. So 21 is equal to 3 times A, because that's Becky's age. All right, we're going to solve for A. So we're going to divide both by 3. 7 is equal to A. And that was it. That one's pretty simple. This should be an easy 2-pointer. But you have to have the equation and you have to solve for A. So you had to have both. Those 2 things had to happen somewhere in your work. All right, and let's go to the next one. Here are the 2 things. This is the last question. This is worth 3 points. So you need some type of equation equals y equals 160x or something equivalent to that, and 1,920 pencils. So let's go through. An office supply store sells boxes of pencils. Each box contains 160 pencils. Write an equation that represents the total number of pencils. So this is what's in the box. And the X is just telling us the boxes. And this is the total number of pencils. That one's pretty easy. So then the next part is, if X equals 12 for 1 day of sales, find the total number. So you would have to take Y equals 160 times X, and you're going to substitute 12 for 160. Put it in parentheses, or write 160 times 12. And that's how you would have gotten 1,920. So all those things, they want to be able to see the substitution. They want to see that you can actually follow through with it to get to a final answer. And you needed the equation. So that's it. Those are all the different parts. This was the very last question for the last day of the exam. I put in all the points. And hopefully this is really helpful in showing you your work and helping you to study and prep for the exam. Good luck. Ask more questions if you need it. I know you can do really, really well, and we'll have more videos if you find you're still struggling, and give suggestions if there's something in math you would love to see. That's it for today, Math Marbles. Good luck on your 6th grade test on Tuesday and Wednesday. See you next time.